Free Atlas. What the new images actually show. Over the past 2 weeks, we've received multiple new images of this object. Different observers, different countries, different telescopes. So, we're going to take them one by one and see what each image adds to the picture. We start here for a reason. This is a clean, ground-based image. Natural color, minimal processing. What we see is a compact central condensation surrounded by a smooth, faint dust coma. There's no sharp jet here, no dramatic cavity, no obvious disruption. This image sets the baseline before filters, before enhancement, before interpretation. At this stage, 3i Atlas looks stable, dust-dominated, and well-behaved. Now we add motion. The stars are stree because the telescope is tracking the object itself. That tells us direction, and it tells us geometry. What matters most is what does not change. The coma stays compact. The dust remains aligned. There's no sudden restructuring. Different night, different observer, same behavior. That consistency is already a signal. Now contrast is enhanced. False color doesn't add new features. It amplifies brightness differences that already exist. Hey, the dust environment becomes asymmetric. One side is brighter, more structured. This is often where people start thinking in terms of jets. But at this point, all we can say is this. The dust distribution is directional, shaped by geometry. And that's not unusual, especially when viewing an object close to its orbital plane. This is the most misunderstood image in the sequence. The Larson Secondina filter removes symmetric coma light and exaggerates gradients. That's its purpose. Here the sunward antitail becomes sharp, almost jet-like. But this is not raw material flow. This is dust density contrast amplified by processing and shaped by projection. Large, slow dust grains remain confined to the orbital plane. When our line of sight intersects that plane, the dust appears sunward. The filter makes that geometry impossible to ignore. It reveals structure. It does not create new physics. Now we zoom all the way in. This is Hubble, a completely different scale. If something fundamentally different were happening near the nucleus, this is where it would show up. Instead, we see the same thing. The same orientation, the same directional structure, the same sunward alignment. Even the apparent brightness depression fits naturally into this picture. A line of sight effect, not missing material. Different instrument, different resolution, same story. When these images are viewed in isolation, it's easy to overread them. When they are viewed together, a pattern emerges. 3 Atlas shows a structured, dust-dominated environment strongly shaped by geometry, stable across time, observers, and instruments. There's no need to invoke anything exotic here. This is what careful analysis looks like. Compare, align, repeat, then conclude. So, the real question isn't whether one image looks strange. It's why the structure stays consistent no matter who observes it or how it's processed. That's where the real science lives. What do you think these images actually show? Share your thoughts below. And if you want more slow image-by-image analysis like this, subscribe and stay with the series. We'll keep following the data one frame at a time.